So in the previous example, or in the previous lesson, we learned what a projectile is. So when you throw something at an angle to the horizontal, the path that it makes is what we call a projectile path. And this motion, we name it as projectile motion. And any projectile motion has two components or projections. So one is the horizontal projection. So it comes all the way up here. And the vertical projection is simply like you throw it up and it comes down. Right? So we have two projections. So we need to find out what are the corresponding velocities and other parameters that are related to that. So we know that the velocity in the horizontal direction, the component, is v cos theta, and the vertical one would be v sine theta, right? So that is going to be reflected in the projections as well, because this is going to move with a velocity of v cos theta, and this is going to have a velocity of v sine theta initially. Then we have the acceleration due to gravity. So we know that the acceleration due to gravity is always pointing down. And since there are no, or there is any force in the horizontal direction, so the acceleration in the horizontal direction is 0. So acceleration in the horizontal direction is 0. So I'm going to draw it like here, ax, x for the horizontal direction. And we are going to have acceleration due to gravity, which is g, pointing down. So there are a few terminologies that you should be familiar with in this projection. So the first terminology is very simple. It is the maximum height that the projectile particle has reached. So I'm going to call it hmax. And the horizontal distance it has covered during this projection or projectile path is what we call a range. So R for range. Okay. So we have to figure these out. So first of all, I'm going to calculate or find the flight time. Right, flight time. So what I'm going to use to calculate the flight time is the vertical projection, right? Because the vertical projection, I know the velocity, initial velocity, and from the previous examples we have done in kinematics, we know that the final velocity is going to be opposite to whatever we have initially, as long as they are at the same horizontal height level. So I'm going to use this equation. Final velocity is equal to initial velocity plus the change in velocity, and I'm going to use it in the upward direction from the start to the point N, which is A to B. I no longer write those. Those are to give you the understanding, but now that you all are familiar with the way that these equations work, you don't need to write everything. So the final velocity is pointing down, but I'm considering anything up as positive, so it is minus v sine theta. Initial velocity is v sine theta is up and it is positive, plus A is pointing down, and I'm considering up as positive and gt. So if I rearrange this equation, I would get 2v sine theta as gt. So from here, I can find the time of flight as 2v sine theta divided by g. So this is the time of flight from start to the very end. And from previous examples, we know that if it takes t amount of time to come back to the same position, it takes t by 2 amount of time to reach the maximum height. It is literally half-half. So the maximum height is reached at t equals to v sine theta over g. And as it reaches here, the time is 2v sine theta over g. So the second thing that I can find out is the maximum height. So how can we find that out? So we can use the vertical projection again, and we are looking at the maximum height, which is here, right? At this height, we know that the velocity is going to be 0, which is final. So I'm going to use the equation Vf squared equals to Vi squared plus 2a delta y in the upwards direction. So the final velocity is 0. Initial velocity is v sine theta whole thing squared plus 2. Acceleration due to gravity is minus g because I am using, like, I'm considering anything up as positive. And the displacement is up and it is h max. So I can rearrange this equation. So I would get h max as v squared sine squared theta divided by 2g. Right. So we have got the flight time, we have got the maximum height. So the one thing that is left out is the range. So how can we find the range? So in order to find the range, we have to use something that shows the range, which is the horizontal projection. So now only we are moving on to the horizontal projection. So for this one, we use the vertical projection. For this one, we use the vertical projection as well. But for the next one, we are going to use horizontal projection. So I'm going to use this equation, delta x equals to VIT plus half AT squared, because I have to relate the displacement to the initial velocity. And since the acceleration in that particular direction is 0, this equation pays me off though, right? So the horizontal displacement is the range, which is r. Initial velocity is v cos theta. And the time it takes is from very start to the very end, which is 2v sine theta over g. So I can rearrange this and I will get v squared 2 sine theta cos theta over g. So in math, you would have learned that sine 2 theta, you can expand this as 2 sine theta cos theta. So I can substitute sine 2 theta instead of the 2 sine theta cos theta. So I will get the range as v squared sine 2 theta divided by g. By no means, please don't memorize any of these equations, but understand how to derive these equations, right? Because none of the questions that we will deal are going to look exactly like this, right? But understand the way that I choose the equations, why I'm choosing the vertical projection for some, why I'm using the horizontal projection for some, why I haven't chosen a different equation, but these specific equations, right? So there are always reasonings behind these, and understand the differences and the reasonings. We'll look some examples. If you have any doubts, please let me know. Otherwise, we'll move on to the examples.